Hello everyone and welcome to the lecture on AWS Resource Access Manager, AWS RAM. So this lecture will contain all these topics. What is AWS Resource Access Manager, benefits of AWS Resource Access Manager, cross account access with resource based policies, AWS RAM features, how resource sharing works in RAM, sharing your resources, using shared resources, consuming principles, and resource based policies, along with all the shareable resources that is possible to share with Resource Access Manager. So what is AWS Resource Access Manager? AWS RAM enables you to securely share your resources with other AWS accounts, ensuring that access is granted only to authorized entities. If your account is part of an AWS organization, you can share resources with all AWS accounts in the organization or specific organizational units (OUs). AWS RAM allows you to share resources with IAM roles and users, providing granular access control based on identity and permissions. With AWS RAM, you can create a resource once and make it accessible to multiple AWS accounts, reducing the need for duplicating resources. If desired, you can share resources with all accounts within your AWS organization, streamlining resource management across the entire organization. AWS RAM provides the flexibility to share resources with specific organizational units or individual AWS account IDs, enabling targeted resource sharing. So basically, to summarize, you create a resource in single AWS account, then you can share with other AWS account. It can be in the same AWS organization or part of OU in the organization, or altogether a different AWS account belonging to someone else. So all three use cases are possible. So benefits of AWS Resource Access Manager. AWS RAM allows you to create a resource once and share it with other AWS accounts, which eliminates the need to provision duplicate resources in every account. And this simplifies granting access to roles and users within the resource owning account without using identity-based permission policies. With AWS RAM, you can simplify security management for shared resources using a single set of policies and permissions. This ensures consistency across all AWS accounts sharing the resource, avoiding the need to maintain identical policies and permissions in each account separately. AWS RAM integrates with Amazon CloudWatch and AWS CloudTrail, which allows you to view usage details for your shared resources. This provides comprehensive visibility into shared resources and accounts, enabling effective monitoring and auditing. So let's see cross-account access with resource-based policies. So this is a traditional way. So if you don't use Resource Access Manager, so you can share some types of AWS resources with other AWS accounts by attaching a resource-based policy that identifies AWS identity and access management IAM principles, which can be IAM roles and users, outside of your AWS account. However, sharing a resource by attaching a policy does not take advantage of the additional benefits that AWS RAM provides. So now let's see by using how this gets simplified by using AWS Resource Access Manager. So this is the feature which is extra provided instead of using resource-based policy. So you can share with organization or an organizational unit without having to enumerate every one of the AWS account IDs. So imagine you have a large organization and there could be 10, 50s or hundreds of account IDs. You have to create a lot of resource-based policies and identity and access management IAM policies. But this will, if you do it through AWS Resource Access Manager, you can share it across the whole organization, or you can group multiple account IDs into an OU, and then you can just share it with the OU also. Users can see the resources shared with them directly in the originating AWS Service Console and API operations, as if those resources were directly in the user's account. For example, if you use AWS RAM to share an Amazon VPC subnet with another account, users in that target account can see the subnet in the Amazon VPC console and the results of Amazon VPC API operations performed in that target account. Resources shared by attaching a resource-based policy are not visible this way. So this is the downside. Means if you are using resource based policy, so in this resource access management there is no downside. Instead, you have to discover and explicitly refer to the resource by its Amazon resource name. So if you use resource based policies, there is no other way but you have to know the Amazon resource name. So you must have the explicit knowledge about what is being shared by other from the host account. The owners of a resource can see which principal have access to each individual resource that they have shared. So at the owner account also can see which all principals have access to the individual resource. So both parties get the benefit. If you share resources with an account that is not part of your organization, then AWS RAM initiates an invitation process. So this is outside of your organization. So AWS RAM will initiate an invitation process. The recipient must accept the invitation before that principal in the target account, I mean to say, before that principal can access the shared resources. After you turn on the ability to share within your organization, sharing with accounts in the organization does not require invitation. So only outside your AWS account it needs invitation, which are not part of your organization. Same organization, there is no invitation. So how resource sharing works in AWS or Resource Access Manager? So when you share a resource from the owning account or the owner account with another account, the consumer account or the target account, you are granting access to that resource. Principals, which can be roles and users in the consuming account, are granted access to the shared resource from the owning account. Any policies and permissions that apply to roles and users in the consuming account also apply to the shared resource, ensuring consistent access control. The resources in the share look like they are native resources in the AWS accounts you shared them with, which providing a seamless experience for the consuming accounts. AWS allows you to share both global resources and regional resources across accounts using the resource sharing mechanism. Okay, sharing your resources. So we'll see the procedure. So with AWS RAM, you share resources that you own by creating a resource share. So there is an object called resource share, and to create a resource share, you specify the following: the AWS region in which you want to create the resource share. A resource share can contain only regional resources that are in the same AWS region as the resource share. A resource share can contain global resources if the resource share is in the designated home region for global resources. For example, US East North Virginia, US East 1 region. Then you provide a name for the resource share and the list of resources that you want to grant access to as part of this resource share. Next, you will provide the principals to which you grant access to the resource share. So principals can be individual AWS accounts, the accounts in an organization or organizational unit in AWS organizations, or individual AWS identity and access management roles or users. Then you provide a managed permission to associate with each resource type that you include in the resource share. The managed permission determines what principals in the other accounts or the consuming account or the target accounts. So what the principals in the consuming accounts can do with the resources in the resource share. So owner is basically deciding the permissions, and the consumer is abiding by or is adhering to the what you have given the permissions in the owner account. The behavior of the permission depends on the type of the principal. If the principal is in different account from the one that owns the resource, then the permissions attached to the resource share are the maximum permissions available to be granted to roles and users in those accounts. The administrator of those accounts must then grant individual roles and users access to the shared resource with IAM identity based policies. The permissions granted in those policies cannot exceed those defined in the permissions attached to the resource share. So you have source and target. So if source is giving the maximum possible, then the target can actually reduce it, but it cannot override, or it cannot give more than what the source account has given. The resource owning account retains full ownership of resources that it shares. So still the resource owner still own the whole ownership. So it can, if the owner want to take away the permissions or don't want to share it anymore, they can take it back. So how to use using shared resources? So when the owner of a resource, so this is how to use the shared resources. Now we are talking about the consumer or the target account. When the owner of a resource shares it with your account, you can access the shared resource just as you would if your account owned it. The API operations that principals in your account are allowed to perform vary depending on the resource type and are specified by the AWS RAM permissions attached to the resource share. This comes from the source account. All IAM policies and service control policies configured in your account also continue to apply, which enables you to make use of your existing investments in security and governance controls. When you access a shared resource using that resource's service, you have the same abilities and limitations as the AWS account that owns the resource. If the resource is regional, then you can access it from only the AWS region in which it exists in the owning account. If the resource is global, then you can access it from any AWS region that the resources, service console and tools support. You can view and manage the resource share and its global resources in the AWS RAM console and tools only in the designated home region, which is North Virginia, US East 1. So this is for global resources. So you have to change in the AWS console, you have to change the region to US East 1 to see the global resources. Okay, now let's talk something about consuming principals. So the consuming principals is basically users and roles, they are the consumer in the consuming account. So the consuming account is the account to which a resource is shared. The resource share can specify an entire account as the principal. So just the whole AWS account, just the account ID, so 12-digit number as the principal, and inside that everybody has access. Or for some resource types, it can also, you can fine tune it, like you can mention the role or the users in the target account. So you should know the role or the username in the target account, and you can just restrict the whole permissions to a single user or a role. AWS RAM also supports service principals as consumers of resource shares. The principals in the consuming account can perform only those actions allowed by both of the following permissions. The managed permissions attached to the resource share, these specify the maximum permissions that can be granted to the principal in the consuming account, and the IAM identity based policies attached to the individual roles or users by the IAM administrator in the consuming account. So those policy must allow access to the specified actions and to the Amazon resource name ARN of a resource in the sharing account. So basically it's an AND condition over here. So I said that both the permissions. So one, the source who has shared what all permissions are allowed, and in the target also you can have your own IAM identity based policies. So both must match, or if there is no match, like if only resource based policies are there but IAM policies are not there, both must be, it's an AND condition. So if both are true, then only the consuming principals, which are users and roles, will be able to perform the whatever actions is specified in the resource. Okay, now so AWS RAM supports the following IAM principal types as consumers of resource shares. So first is another AWS account. The resource share makes the included resource in the sharing account available to the consuming account. So this is just altogether different account. Then you have individual IAM roles or users in another account. So some resource types support sharing directly with individual IAM roles or users, and you specify this principal type by its ARN. So this is the example. So whole account, and if you want specific roles or users, you can just give the first you have to give the account ID and a role name, or if you want to give it to a user, you can just account ID followed by user and / username. Then you have service principal. So you can share a resource with an AWS service. So this is for the whole service. To grant the service access to a resource share, service principal sharing allows an AWS service to take actions on your behalf to ease the operational burden. So basically we are specifying a service ID, and let's say this service in the consumer account wants to access some resource. So you just specify the service ID, and that service ID, let's say, depend on the resource, it will be able to perform the necessary action. And to share with the service principal, choose to allow sharing with anyone, and then under select principal type, choose service principal from the drop down list, specify the service principal name in the following format. So this is the format. And finally, you have accounts in an organization. So this is for the organization. So if the sharing account is managed by a AWS organization, then the resource share can specify the organization's ID to share with all of the accounts in the organization. The resource share can alternatively specify an organizational unit OU ID to share with all of the accounts in that OU. A sharing account can share only with its own organization or OU IDs within its own organization. So specify accounts in an organization by the ARN of the organization or the OU. And this is the format. So basically, if all accounts within the whole organization, you just replace ARN organization, your parent management account, and the organization ID. Or if you want only to the organizational unit, so inside OU you can have multiple AWS accounts for better management. So you have to give OU root ID plus OU ID, like this format. And now let's see resource based policy. Resource based policies are JSON text documents that implement the IAM policy language. So unlike identity based policies that you attach to the principal, such as IAM role or user, you attach resource based policies to the resource. So AWS RAM authors resource based policies on your behalf based on the information you provide for your resource share. You must specify a principal policies element that determines who can access the resource. So basically, under the hood, it will also create the necessary resource based policies. The resource based policies generated by AWS RAM are evaluated along with all the other IAM policy types. It can be IAM based policies. It can be any other kind of access control list, and this includes any IAM identity based policies attached to the principals who are attempting to access the resource. You can have service control policies for AWS organizations that might apply to the AWS account. And finally, resource based policies generated by AWS RAM participate in the same policy evaluation logic as all other IAM policies. So this part doesn't change, the policy evaluation logic. And AWS RAM provides a simple and secure resource sharing experience by providing easy to use abstraction resource based policies. For those resource types that support resource based policies, AWS RAM automatically constructs and manages the resource based policies for you. For a given resource, AWS RAM builds the resource based policy by combining the information from all of the resource shares that include that resource. And finally, we'll see all the resources which are possible to be shared. So these are the services. It's AWS App Mesh, AWS App Sync GraphQL API, Amazon Aurora, AWS Private Certificate Authority, Amazon Data Zone, AWS Code Build, Amazon EC2, EC2 Image Builder, Amazon FSx for OpenZFS, AWS Glue, AWS License Manager, AWS Marketplace, AWS Migration Hub Refactor Spaces, AWS Network Firewall, AWS Outpost, Amazon S3 on Outpost, AWS Resource Explorer, AWS Resource Groups, Amazon Route 53, Amazon Route 53 Application Recovery Controller, Amazon Simple Storage Service S3, Amazon SageMaker, AWS Service Catalog App Registry, AWS Systems Manager Incident Manager, AWS Systems Manager Parameter Store, Amazon VPC, Amazon VPC Lattice, and Amazon Cloud WAN, Wide Area Network. And that's all. Thanks for